It's practice A for 1.2. We left off with number 10. We're going to plot the given points in a coordinate plane, then determine whether the line segments named are congruent. So they give you four ordered pairs. They want to know if segment AB and segment CD are congruent segments. Remember, congruent segments have the same length. So the first thing we're going to do is plot them. Then we're going to see how long they are. Then we're going to compare them. So here's your origin. Point A lives at 2, 2, so we're going 2 to the right and 2 up. It's always good to know the scale on your coordinate plane. That's your point A. Point B lives at positive 2, negative 1. I'm just going to connect those. That's segment AB. I'll put an A here and a B here. Hopefully that doesn't mess me up with the next one. Point C lives at 0, negative 2, 0, negative 2. And then point D lives at positive 3, negative 2. So that B that I put there is kind of in the way. But that's point D and that's point C. And that's our segment length there. So don't just say, yeah, they're congruent, or no, they're not. Like, you need to show your work from A to B. How far is that? Well, this is a vertical segment, thank goodness. So you can count its length. 1, 2, 3 units. You could have also subtracted 2 minus negative 1. That's like 2 plus 1, which gives you the same 3. Remember, segment lengths are always positive. So when we start messing with negative coordinates, you might do something goofy where you think a segment length is negative, and it's not. That is not possible. Anything that you're measuring has a positive length. How far is it from C to D? Again, this is horizontal, which is good. And you should have known it was horizontal from the beginning, because look at these y coordinates. See how they're the same? How far is it from C to D? You can count. 1, 2, 3. You could have subtracted as well. 3 minus 0. Are these segments congruent? Yeah. So I'm going to write this down just so you understand what we're talking about here. These segment lengths are equal. Remember, this is what a segment length looks like. They're equal. Well, if the lengths are equal, then the actual segments, they're congruent. Number 11. Same type of thing. You have some different ordered pairs. E lives at negative 3. Let me notice my scale first. We're still counting by ones. Okay, that doesn't always happen, but we are in this one. It's always good to look first. 1, 2, 3 to the left and 2 up. That's point E. Point F lives 1 to the right and 2 up. Okay, so another horizontal segment. And again, you know it's horizontal because the y values match. So that's a good thing. We can count its length. Let's look at segment GH. G lives at 2, 3, positive 2, positive 3. H lives at positive 2, negative 2. So again, I've got my F in the way there. F is this guy, G is this guy. That's a vertical segment, and you know because the X values are the same. You can count their lengths. How far is it from E to F? That's how you write it. This is the length of segment EF. 1, 2, 3, 4 units. How far is it from G to H? Let's count. 1, 2, 3, 4, 5. They're not the same. Now, when you're counting lengths, you're counting the spaces. Don't count the lines, because some of us end up counting here and then here and then here, and you're counting lines that go in between E and F. Some of us, our brains are kind of wired that way. You want to think of it as spaces. So this is one little space. That's 2, that's 3, and that's that's 4. That's how we're going to count them. Are these segments congruent? They're not. Their lengths are different, so I'm going to write this. E to F, that's a length. G to H, that's a length. They're not equal. See how I put that slash in between? So if they're not equal lengths, then the segments, my pen's dying, the segments are not congruent. So I put that slash through there. Okay, this bottom segment, we're not in a coordinate plane anymore. Up here we were in a coordinate plane, 2 dimensions. We got an x and a y coordinate. Axis, rather, x and y axis. Down here we have a number line. It's just one dimensional. We're moving left and right. We want to find these lengths. So you can find them by counting or you can find them by subtracting. That's your ruler postulate. So maybe we will do a couple each way. Number 12, how far is it from J to K? Maybe we'll do this one just by counting because it's kind of simple. 1, 2, 3, 4, 5. 5 units. Now, you could use the ruler postulate as well, and you could subtract those. So we have a coordinate of -8 and -3. We know that those lengths are always positive. So in your calculator, if you hit the math button, here I'll show you, your math button's right here. You hit that button and you go over to number, you can take the absolute value of some things. And that's what the ruler postulate is. It's the absolute value of your difference. So absolute value of -8 and -3. Boy, this better give us 5, otherwise math doesn't make a lot of sense. And it does. Okay. Now, I could have done the same thing. What if I would have put the numbers in the other way? My coordinates are still -3 and 8. If I find the difference going that way, I better still get the same answer, and I do. And again, notice how they're positive. Your lengths are positive always. Okay, so that's how you use your ruler postulate. That calculator is ready to die, so I may not show that again, but that's a good way to show how to use it. For number 13, we're going from K to L. We're going from -3 to +1. That's 4 units. Again, you could just count the spaces if you want to. If you don't like counting, you could do -3 minus +1. That gives you -4, but you're taking the absolute value. Lengths are positive. Number 14, L to M. We're going from 1 to 7. That's 6. You could just do 7 minus 1. That's simple enough, or count. J to L. We're going from -8 to +1. Count those spaces. There's 9 of them. You could have done -8 minus -1. That gives you -9. Absolute value gives you +9. J to M, we're going from -8 to +7. Count those spaces if you want to. That gives you 15. This is where, when you start dealing with number lines like this, where you're counting a whole heck of a lot, it might just be easier to subtract. So it's good to be versatile and good to be light on your feet so you can decide which method you're going to go with depending on how far apart the points are. 7 minus -8. That's like 7 plus 8. It's 15. And again, if you're not cool with those calculations in your head, use your calculator. Number 17, K to M. We're going from -3 to 7. I didn't talk about doing it this way. Here's another way to do it too. Notice how 3 is to the left of 0, obviously this -3. So 3 more units will put you at 0. And then obviously 7 more units will put you at M. So you have 3 units here and 7 units there. From -3 to +7. That's 10 units.